In the realm of DevOps, a comprehensive testing strategy is crucial for ensuring the quality and reliability of software. This strategy encompasses various types of tests, each serving a unique purpose in the software development lifecycle. From local tests to load tests, each step is designed to catch different types of issues, ensuring that the final product is robust and performs well under various conditions. This presentation will delve into the different aspects of a comprehensive testing strategy, providing insights and examples to help you design and implement an effective testing pipeline. Testing is a fundamental component of the DevOps lifecycle. It ensures that code changes do not introduce new bugs and that the software performs as expected. By integrating testing into the build and release pipelines, teams can catch issues early, reducing the cost and effort required to fix them. Moreover, a well-defined testing strategy helps in maintaining high-quality standards, improving user satisfaction, and ensuring compliance with industry regulations. In essence, testing is not just about finding bugs, it's about building confidence in the software. Local tests are the initial tests run by developers on their machines before committing code to the repository. These tests are crucial as they catch issues early in the development process, saving time and resources. Local tests typically include syntax checks, code style validations, and basic functionality tests. By running these tests locally, developers can ensure that their code meets the project's standards and does not introduce obvious errors. This step is essential for maintaining a smooth and efficient development workflow. Unit tests focus on individual components or functions within the codebase. These tests are designed to validate that each unit of the software performs as expected. Unit tests are typically automated and run frequently to catch issues early. They are essential for ensuring code quality, as they help identify bugs at the smallest level of the application. By writing comprehensive unit tests, developers can ensure that their code is reliable, maintainable, and free of defects. Examples of unit tests include testing a function's output given specific inputs or verifying that a method handles edge cases correctly. Integration tests focus on the interactions between different components or systems. These tests ensure that the integrated units work together as expected. Integration tests are crucial for identifying issues that may not be apparent in unit tests, such as data flow problems, interface mismatches, or incorrect assumptions about component interactions. By running integration tests, teams can validate that the system as a whole functions correctly. Examples of integration tests include testing the interaction between a web server and a database, or verifying that an API correctly processes and returns data. Load tests are designed to evaluate how the system performs under various levels of demand. These tests simulate real-world usage scenarios to identify performance bottlenecks, scalability issues, and potential points of failure. Load tests are essential for ensuring that the application can handle expected user traffic and perform well under stress. By conducting load tests, teams can gain insights into the system's capacity and make informed decisions about infrastructure and optimization. Examples of load tests include simulating a high number of concurrent users accessing a web application or testing the response time of a database under heavy load. Designing a testing pipeline involves integrating various types of tests into the build and release process. This pipeline ensures that code changes are thoroughly tested before being deployed to production. A typical testing pipeline includes stages for running local tests, unit tests, integration tests, and load tests. Each stage is automated to provide quick feedback to developers and catch issues early. By designing an effective testing pipeline, teams can maintain high-quality standards, reduce the risk of defects, and ensure a smooth and reliable release process. Implementing local tests involves setting up tools and frameworks that allow developers to run tests on their machines. This step typically includes configuring linters for code style checks, setting up unit testing frameworks, and creating scripts to automate the testing process. By providing developers with the tools they need to run local tests, teams can ensure that code quality is maintained from the very beginning of the development process. Examples of tools for local testing include ESLint for JavaScript code style checks, JUnit for Java unit testing, and PyTest for Python testing. Implementing unit tests involves writing test cases for individual functions or components within the codebase. This step requires selecting appropriate testing frameworks, writing test scripts, and integrating these tests into the build process. Unit tests should be automated and run frequently to provide quick feedback to developers. By implementing comprehensive unit tests, teams can ensure that their code is reliable and free of defects. Examples of unit testing frameworks include JUnit for Java, NUnit for .NET, and Mocha for JavaScript. Implementing integration tests involves setting up test environments that mimic the production environment and writing test cases that validate the interactions between different components. This step requires configuring test databases, setting up mock services, and writing scripts to automate the testing process. Integration tests should be run as part of the build pipeline to catch issues early. By implementing effective integration tests, teams can ensure that their systems work correctly as a whole. Examples of tools for integration testing include Postman for API testing, Selenium for web application testing, and test containers for testing with Docker containers. Implementing load tests involves setting up tools and frameworks that can simulate real-world usage scenarios and measure the system's performance under stress. This step requires configuring load testing tools, writing test scripts, and integrating these tests into the build pipeline. Load tests should be run regularly to identify performance bottlenecks and ensure that the system can handle expected user traffic. By implementing effective load tests, teams can gain insights into the system's capacity and make informed decisions about optimization. Examples of load testing tools include Apache JMeter, Gatling, and Locust. Continuous testing is the practice of running automated tests throughout the software development lifecycle. This approach ensures that code changes are continuously validated, providing quick feedback to developers and catching issues early. Continuous testing involves integrating various types of tests into the build and release pipelines, automating the testing process, and monitoring test results. By adopting continuous testing, teams can maintain high-quality standards, reduce the risk of defects, and ensure a smooth and reliable release process. Continuous testing is a key component of a successful DevOps strategy. Monitoring and reporting are essential components of a comprehensive testing strategy. By tracking test results and generating reports, teams can gain insights into the quality of their code and identify areas for improvement. Monitoring tools can provide real-time feedback on test performance, while reporting tools can generate detailed reports on test coverage, pass-fail rates, and other metrics. By implementing effective monitoring and reporting practices, teams can ensure that their testing strategy is effective and continuously improve their processes. Examples of monitoring and reporting tools include Jenkins for continuous integration, SonarQube for code quality analysis, and Grafana for visualizing test results. To design and implement an effective testing strategy, teams should follow best practices, such as writing clear and concise test cases, automating tests wherever possible, and continuously reviewing and improving their testing processes. Other best practices include maintaining a clean and organized codebase, using version control for test scripts, and ensuring that tests are run in a consistent and reproducible environment. By following these best practices, teams can ensure that their testing strategy is effective and that their software is of high quality. Examples of best practices include using descriptive names for test cases, setting up continuous integration pipelines, and regularly reviewing test coverage. In conclusion, a comprehensive testing strategy is essential for ensuring the quality and reliability of software in a DevOps environment. By implementing local tests, unit tests, integration tests, and load tests, teams can catch issues early, reduce the risk of defects, and ensure a smooth and reliable release process. Continuous testing, monitoring, and reporting are also crucial components of an effective testing strategy. As a next step, teams should review their current testing practices, identify areas for improvement, and implement the best practices discussed in this presentation. By doing so, they can ensure that their software is of high quality and meets the needs of their users.